In this video, we're going to take a look at the derivatives of tangent, secant, cotangent, and cosecant. We will look at some examples that involve those derivatives. So here you can see I have these derivatives just written down. The derivative of tangent is secant squared. Derivative of secant is secant x tangent x. The derivative of those cofunctions, cotangent, is negative cosecant squared. The derivative of cosecant is negative cosecant x, cotangent x. We won't go through this with all of them, but for tangent, if we were to find that derivative, we could say, so that derivative rule, it is what it is, but let's argue that it is what it is. So tangent is sine over cosine. And so if we were to take the derivative of sine over cosine, we would have a quotient rule. So it's low, d high, right? Derivative of the top is cosine, so we'd have cosine squared on top, minus high, sine x, d low. Derivative of cosine is negative sine, so we have cosine squared plus sine squared, all over low squared. Low d high minus high d low, square the bottom, and away we go. The top, that is just a Pythagorean identity. Sine squared plus cosine squared is 1, so we have 1 over cosine squared x. 1 over cosine is secant, and so we get secant squared x. Yeah, and you could do that with any of these. You can roll through our quotient rules and end up getting some of these different arguments, derivative of cotangent, cosecant, all of those fun things. All right, but let's apply these things now. Let's find some derivatives involving, so first tangent. So f prime of x. So our function is tangent x over x squared plus 1. We have low, d high, so we're going to take the derivative of tangent. Derivative of tangent is secant squared, minus high, d low. Derivative of the bottom is just 2x, so 2x plus 0, all over the bottom squared. Excellent. For the second example, we have x squared times secant x. So we have a product of these two things. Our first piece is x squared. Our second piece is secant x. So our product rule says it's the first times the derivative of the second. The derivative of secant of x is secant x tangent x. So it's x squared secant x tangent x plus the second secant of x times the derivative of the first. Derivative of x squared is 2x. And that is derivatives involving trig functions. They can certainly get more complicated than this, depending on how you stack these derivative rules. But for trig functions, these are the derivatives that you should learn, you should get down. You will use those and it will make your life easier if you know those. All right, we will talk to you later.